Hello, ladies and gentlemen. We're going to do 5.7 today. We're going to be integrating our inverse trig functions. Our objectives are obviously that we're going to integrate our inverse trig functions, and then in a problem we are going to use completing the square to force the relationship so that we can integrate a trig function. I do want to go back and talk about first, though, the derivative of our six trig functions. So the derivative of our six trig functions, they fall into three pairs. Alrighty, and each pair, one derivative is the negative of the other derivative. So if you ever have to go back and look at your notes, that will make absolutely no sense, but it just is the pattern that I wanted you to see, and in case you didn't see it, then I was going to point it out for you. So for example, the derivative of the arc, and these are our six arc trig functions, if I write it politely, the derivative of the arc sine of x is 1 over the square root of 1 minus x squared. Well, then the derivative of the arc cosine of x is a negative 1 over 1 minus x squared. And remember, the last time we wrote these down, we used u's because the u's represented if you had to do the chain rule, but for right now, I'm just going to do this simple formula. If I have the derivative of the arc tangent of x, then this is 1 over 1 plus x squared. Well, then the derivative of the arc cotangent of x is going to be a negative 1 over 1 plus x squared. And then the last set, or the last pair, if I do the derivative of the arc secant of x as 1 over, this is the one that's really yucky, I think, x squared minus 1, then the derivative of his buddy, the arc cosecant of x, is a negative 1 over the absolute value of x, x squared minus 1. So that's just kind of an interesting relationship to show. Sorry, it's what happens when you record too many videos in a day. So now I want to talk about the integration rules. So now let's do our integration. So if I have the integral of 1 over the square root of a squared minus u squared du, and in these, let's talk about this is going to be a constant, and this is going to be an expression involving x, okay, or some other variable, then this is going to equal the arc sine of u over a plus c. Remember, it's an indefinite integral, so we can't forget our c's. The next integration rule is going to be 1 over a squared plus u squared, because remember, a is going to be some type of constant, and it doesn't have to be a polite, pretty number, because if I were to have 5, 5 is the same thing as the square root of 5 times the square root of 5, so it's the square root of 5 squared. So it doesn't have to be a polite, pretty number. And then I get my du in there. Well, this is 1 over a times the arc tangent of u over a plus c. I guess it would be polite to put parentheses around those guys. And then the last one, and I'll squeeze it in right here, would be the integral of 1 over u times the square root of u squared minus a squared du, and this is going to equal 1 over a times the arc secant of the absolute value of u over a plus c. And again, this is just like what we talked about when we did the derivatives. You're just going to have to memorize these and do your best to make sure that you can make this work. Because sometimes these problems tend to be a little bit mind-boggling, they're not difficult, but it just takes a little while to recognize them and to set them up, I would recommend that you write all of these little formulas down and have it on a sheet of paper by your side when you get ready to start working on these. All right, so now let's walk through some examples. And I'm only going to do, I think, 4 because these get to be a little bit entertaining. So the first example, I want to do the integral of dx over 2 plus 9x squared. So remember, my u needs to be the square root of the variable thing. So this is going to be 3x, and then du is going to equal 3 dx. So it's a combination of u substitution and otherwise. And then I'm going to let my a equal the square root of 2. So I do need to worry about introducing the 3, but if you'll notice what we have, and I'm just going to write it kind of simply, is we're going to end up with 1 over a squared plus u squared du. So that's what we're trying to get to. I do have to worry about when I do my du, so I need to introduce the third. So on the outside of my integral, I'm going to introduce the third, and then I'm going to write this as 3 dx over the square root of 2 squared plus 3x squared. Okay? Well, now I have my 3's are managed, and so technically this is going to turn into 1/3. Sorry, I don't want to say that. I want to say this. If I have this integral, then this is going to equal 1 over a times the arc tangent of u over a plus c. So that's what I have. Now I'm just going to manage my math. So then if I do this, sorry, here's the third, and then I have 1 over a, but remember a was the square root of 2, so it's going to be 1 over the square root of 2 times the arc tangent. U is 3x, a is the square root of 2, that stuff is all inside, and then plus c. So the only thing that I would do to clean that up, I would say the integral of f of x dx is equal to 1 over 3 radical 2 arc tangent 3x over radical 2, and that's just yucky, plus c. And then you're actually done. So that one wasn't too bad. Alrighty. So in my next one, I want to have the integral of dx over e to the 2x minus 1. So it looks like, so I'm going to let u equal, sorry, brain and mouth aren't working at the same speed. U is going to equal e to the x. So then du is e to the x dx. So this was a wee bit tricky because notice that if I have u, this is going to be u squared minus a squared. So a is going to equal 1. But I have a dx on the top. So what I need to do is I'm going to solve this for dx. So dx is going to equal du over e to the x, which is the same thing because I let u equal e to the x. So this is du over u. Alrighty? So now what I'm going to do is substitute all of that information in. So this is going to become, so my dx is du over u over the square root of u squared minus a squared. We'll just write it like that. Okay? And actually, I don't want to do that. I'm going to write that as 1. So then I need to manage that u guy. So I'm going to have this be 1 over u times the square root of u squared minus 1. And then I can put my du right there. Well, if a is 1, so this was a squared, so I guess I can write that minus a squared. And I'll write this as minus a squared so you can compare it to the rules that we wrote down. Well, then this is going to be 1 over a times the arc secant of the square root of u over a plus c. Well, now I just need to substitute all of my values in. And remember I said, because these are really hard to memorize, have that sheet handy so you can look at where you're trying to go. So then if I do this math, my integral of f of x dx is going to equal, so 1 over a, so 1 over 1 times the arc secant, the square root of u, so the absolute value, wrong math term, over 1 plus c, and just to clean it up, so my integral of f of x dx is going to equal the arc secant absolute value, oops, he goes up there, plus c. Alrighty, so that one was done. Whew, sometimes these just get to be rather entertaining. Alright, the next example, got to have a different color because it makes our math so much fun. Alright, this one I'm going to have the integral of x plus 2 over the square root of 4 minus x squared dx. Alright, so in this one, I'm going to split it up into two separate integrals. So I'm going to split this up, and I'm going to have the integral of x over 4 minus x squared dx plus the integral of 2 over, and then the square root of 4 minus x squared dx. So I'm going to manage kind of one at a time. So I'm going to manage this one first. So I'm going to let u equal 4 minus x squared. So du is going to equal a negative 2x dx. All right, so if you'll notice, up here, I need to introduce the negative 1/2. So I'm going to do this first one, and then I'm just going to carry this one around until I get ready to manage him. I will take the 2 out front because that's pretty easy. So my first integral is going to become, I'm going to introduce the negative 1/2 to counterbalance that negative 2. So this is going to be the integral of u to the negative 1/2 du. Because if this is the square root of u, and, in this one, and I have my 2x dx, this is just u substitution. And then I'm just going to manage this guy, and I'm going to make this be dx over 4 minus x squared. Alrighty. So if I go, I'm just still going to go ahead and manage the first one just to be a little bit careful with my math. Well, if I integrate this, this is a negative 1/2 times u, add 1, plus 2 over 2 to the 1/2, and then divide by 1/2, plus c, and I still haven't managed him yet, okay? So I'm just going to write him down, over 4 minus x squared, okay? So then if I manage this math, the 2's cancel, so this is going to end up being a negative u to the 1/2 plus c. Now I'm ready to work on this guy. Well, in this one, I'm going to let u equals x, and my a is going to be 2. So this is plus 2 times the integral of 1 over the square root of a squared minus, oops, that's supposed to be a u squared du, right? Okay, so then if I keep going, I think you can still see, this is a negative, and I'm going to go ahead and substitute my u back in. So this is going to be the square root of 4 minus x squared. I'm just going to put my c right there. Here's the plus 2. Well, this is the arc secant, right? So when I integrate arc secant, so here's going to be the 2. Then I'm going to have the arc, oops, it's not secant, it's sine, the arc sine of u over a in parentheses, and I already have one c, so I don't need to have two c's. Okay, so this is going to be a negative 4 minus x squared plus 2 times the arc sine. My u was x, my a was 2, and then I'm going to write plus c at the end. Woohoo! And I'm going to stick in my f of x dx, and that one's done. All right, the last example that I have, which actually isn't that difficult, but we need to go back and remember this process, is going to be using completing the square. So I'm going to use completing the square in this particular integral. So I'm going to be given the integral of dx over x squared minus 4x plus 7. So if I think about completing the square in the denominator, so I'm just going to to do that first. So x squared minus 4x, push the 7 over, leave some space. Half of 4 is 2, squared is 4, plus 4 minus 4, factor. This becomes x minus 2, quantity squared, plus 3. So if I think about this being the squared term, so this could be my u squared, and this is my a squared, then my integral becomes 1 over u squared plus a squared du. Well, that's the arc-tangent ratio, so I'm just going to rewrite my integral as, I'm going to write 1 over x minus 2, quantity squared, plus 3 dx, which is this right here. So then all I have to do at this point is substitute in, because this is going to be arctangent because it's u squared plus a squared. So then arctangent, I'll write it under this guy, is 1 over a times the arctangent of u over a plus c. Well, I just need to take all of my goodies and substitute it in. Sorry, my paper got all wonky. So it's going to be 1 over a, which is the square root of 3, and then arctangent, and then my u is x minus 2 over my a, the square root of 3, plus c, and then I'm going to clean it up. So the integral of f of x dx is going to be 1 over the square root of 3, arctangent x minus 2 over radical 3 plus c, and we're done. All right, so my word of encouragement would be, these are fairly mind-bending, and they really take some concentration to be able to pull this off. So I would recommend having your integration and your derivatives close, and you need the ones for our arc trig functions. Take a deep breath, drink some coffee, and then let's do some math. Yeah, math. All right, my lovelies, that is it for today. I will see you tomorrow.